What's good, math family? In this video, we're looking at applications of quadratic functions. We're going to break down how to solve and interpret word problems. When we're dealing with this topic, the first thing we need to understand is that 9 times out of 10, the quadratic function is going to be negative. And the reason why it's negative is because when we look at these type of problems, typically it's going to follow or talk about trajectory, meaning we either be on top of a building or just on the ground. We throw something and its pathway is going to be similar to a quadratic equation. So this is why the function is negative. Now, another thing we need to also understand is this: what are the units talking about? When we look at this quadratic function here, we know t is equal to time in seconds, and we know h is equal to height in feet. And the way that we know this is through this little hint from the word problem, right? 50 feet per second. So now that we know that, one of the questions they may ask us is, hey, what is the initial height of the ball, or in this situation, the person being shot out of the cannon? So what does that mean? If they're asking us for the initial height, they're saying, hey, at 0 seconds, so we plug 0 in for t, what is the height? So when we do that, we'll have 0 plus 0 plus 4. So we know h would be equal to 4 feet, meaning the initial at the beginning, before the stunt double is shot out the cannon, they're 4 feet high. That's all that's saying. Now that we understand that, it asks us find the maximum height of the ball. When we look at the trajectory, right, if it looks like a parabola. So if we're asking for the maximum height, we're asking for this point, which is also known as the vertex. And to find the vertex is a two-part process. First, we start off with the formula x is equal to the opposite of b over 2a. So we know b is 50, right? So x is equal to the opposite of 50 all over 2 times a. We know a is negative 16. So when we simplify this, x is equal to negative 50 over negative 32. So when I simplify this one step further, make sure you pay attention to your signs. We know x is going to be equal to 1.56. What does the 1.56 represent? This is seconds. We have to know that. All right. So we know for the vertex, the x coordinate is 1.56. Now we need to find the y. And remember, the y is the height. So all we need to do to figure that out is plug 1.56 back into the quadratic function. So now we have h is equal to negative 16 times 1.56 squared plus 50 times 1.56 plus 4. And now we're just going to clean this up. So h is equal to negative 38.9 plus 78 plus 4. So now once we clean this up, we're going to have h is equal to 38.9 minus 82. We're going to get h is equal to positive 43.1. So this is the answer. So what does the answer represent? We know that the maximum height of the ball is going to be 43.1 feet. And then we can now fill this in for the vertex. So now we answered that question. And the second question asks us, how long will it take to reach the ground? So after we shoot the stunt double into the air, how long will it take them to reach the ground? So we're now trying to figure out, what is this point right here? And what we have to also be mindful of is that the ground represents the x-axis. And if we're trying to figure out the x-intercept, right, typically we're going to factor the quadratic equation so that we can determine that. So when we go back into this problem now, let's erase a little bit, we're going to factor this. And in this situation, the best method to factor this quadratic function is probably going to be the quadratic formula. So we're talking about x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. So we're going to fill this in and determine how long will it take the stunt double to reach the ground. All right, so we have x is equal to negative 50 plus or minus 50 squared minus 4 times a, which is negative 16, times c, which is 4. And we're going to divide all of this by 2 times a, which is negative 16. And just remember, we get a, b, and c from the standard form of a quadratic equation. Ax squared plus bx plus c. So the a term is 16, b is 50, c is 4. Okay, so now we go in and we're going to simplify. So let's do this now. So we have x is equal to the opposite of 50 plus or minus the square root of 2500 plus, and let's do this, 4 times 4, plus 256 all over negative 32. So when we now clean this up, family, all right, this is what we're going to have. X is equal to the opposite of 50 plus or minus the square root of 2,756 all over negative 32. Now at this step, I'm going to tell you, if we could break this down to a decimal, just break it down to a decimal so that we can make this next step easy. So now that we understand that, we now get our two possible answers. So we know x is equal to negative 50 minus, and then let's turn this into a decimal. What is the decimal for this? This is going to be 52.49. So we're going to round it to 52.5 all over negative 32. So once we simplify this now, we're going to get x is equal to positive 3.20. So this is one of our possible answers. Now the next possible answer, let's erase this right here. We're going to do the opposite. So instead of negative 50 minus, we're going to do x is equal to negative 50 plus 52.5 all over negative 32. When we simplify this one step further, family, this is what we should get. So we're going to get negative 0.078. Now, remember what this is saying. It says, how long will it take to reach the ground? And we have two different answers. We have negative 0.078 seconds. Let's just put the units. And we have 3.2 seconds. So this is an extraneous solution, meaning we have to get rid of it because time cannot be negative. They're always going to try to trick you with this. So the correct answer for this, how long will it take to reach the ground, will be 3.2 seconds. But before we go, if you found this video helpful, we're going to ask that you smash the like button for us. It really helps us to get this video out to more students. But before we go, we got two bonus questions that we want to go touch on with you guys. So let's say after solving these two questions, they asked us another two. So the first question is going to be, how long does it take to reach the maximum height? And this is a trick question, family. I really want you to understand. So we know, what is the maximum height? The maximum height is 43.1 feet. How long did it take to get there? You don't have to do additional work. Remember, time versus height. So whatever the x coordinate is for this, that is our answer. So we know at 1.56 seconds, the stunt double is going to reach his maximum height, which is 43.1 feet high in the air. So this is the application that we have to understand. How do these two things relate? Now, the second thing they may ask us, it may not be that easy, meaning they may not ask you how long it would take to get to the maximum height because you did the work. Instead, they may say to you, let's see, what's the best way to frame this? They may say, okay, what is the height after 3 seconds? So how do we solve this? I'm glad you guys asked. Very simple. So if they ask us for the height after 3 seconds, we just have to plug in and solve. We don't know what h is, but we know that if we plug in 3 for t, because t represents time, we could then determine the height of the stunt double. So let's fill it in. All right, so when we simplify now, we're going to have negative 16 times 9 plus 150 plus 4. So let's multiply 16 times 9. So h is equal to negative 144 plus 154, right? So now once we combine these, we know h is going to be equal to positive 10. So we know after 3 seconds, the stunt double is going to be 10 feet high in the air. Really hope this review on applications of quadratic functions was helpful for you, family. If it was, smash the like button for us, subscribe to the channel, and leave comments down below if you had questions on this video or if there's topics you'd like to see on our channel in the future. Thank you guys so much for joining Algebra 1 with Mr. Peters.